NENOMATICA, where mathematics meets YouTube excellence. Welcome to this video where we'll learn about polynomial division, an important concept in algebra. Polynomial division is similar to regular division of numbers, but with polynomial expressions. Let's start with the basic concept. When we divide one polynomial f of x by another polynomial g of x, where g of x is not equal to 0, we can express the result as a quotient q of x plus a remainder r of x divided by g of x. Mathematically, we can write this as f of x equals q of x times g of x plus r of x. The key condition is that the degree of the remainder r of x must be less than the degree of the divisor g of x. Now, let's understand the polynomial division algorithm. Let's look at an example to better understand the process. Let's set up our polynomial division. We have f of x equals x cubed plus 2x squared minus 4x plus 5. This is our dividend. And g of x equals x minus 2. This is our divisor. Let's use the polynomial long division method to find the quotient and remainder. Let's start the polynomial division. First, we divide the leading term of the dividend by the leading term of the divisor. We have x cubed divided by x, which gives us x squared. Now, we multiply the divisor by x squared. So we get x squared times x minus 2, which equals x cubed minus 2x squared. Next, we subtract this from the first two terms of our dividend, x cubed plus 2x squared minus x cubed minus 2x squared, which gives us x cubed plus 2x squared minus x cubed plus 2x squared equals 4x squared. Now, we continue the process with our new dividend, 4x squared minus 4x plus 5. Again, we divide the leading term of this new dividend by the leading term of the divisor. We have 4x squared divided by x, which gives us 4x. Next, we multiply the divisor by 4x. So, we get 4x times x minus 2, which equals 4x squared minus 8x. Now, we subtract this from our current dividend. 4x squared minus 4x plus 5 minus 4x squared minus 8x, which gives us 4x squared minus 4x plus 5 minus 4x squared plus 8x equals 4x plus 5. Let's continue with our new dividend, 4x plus 5. Again, we divide the leading term by the leading term of the divisor. We have 4x divided by x, which gives us 4. Next, we multiply the divisor by 4. So, we get 4 times x minus 2, which equals 4x minus 8. Now, we subtract this from our current dividend, 4x plus 5 minus 4x minus 8, which gives us 4x plus 5 minus 4x plus 8 equals 13. We've completed the polynomial division. Let's summarize our results. The quotient q of x equals x squared plus 4x plus 4, and the remainder r of x equals 13. So, according to our division formula, we can write f of x equals q of x times g of x plus r of x, which gives us x cubed plus 2x squared minus 4x plus 5 equals x squared plus 4x plus 4 times x minus 2 plus 13. Let's verify our answer by multiplying the quotient by the divisor and adding the remainder. First, let's multiply x squared plus 4x plus 4 by x minus 2. We get x cubed plus 4x squared plus 4x minus 2x squared minus 8x minus 8. Simplifying, we get x cubed plus 2x squared minus 4x minus 8. Now, we add the remainder, 13, to get x cubed plus 2x squared minus 4x minus 8 plus 13, which equals x cubed plus 2x squared minus 4x plus 5. This matches our original dividend, confirming our answer is correct. Welcome to our math video on polynomial division. Today, we'll explore the relationship between the degrees of polynomials in a division process. Let's begin by looking at an important formula that shows the relationship between the degrees of polynomials when we perform polynomial division. The formula states that f sub n of x equals g sub m of x times q sub n minus m of x plus r sub m minus 1 of x. This formula is fundamental in understanding how polynomial degrees relate during division. Let's break down this formula. F sub n of x represents the dividend polynomial with degree n. G sub m of x represents the divisor polynomial with degree m. Q sub n minus m of x represents the quotient polynomial with degree n minus m. And our sub m minus 1 of x represents the remainder polynomial with a degree that is at most m minus 1. Now, Let's discuss the steps for dividing a polynomial f of x by another polynomial g of x. The steps are as follows. Step 1. We arrange both polynomials in descending order of the variable x. Step 2. We divide the first term of the dividend by the first term of the divisor to find the first term of the quotient. Step 3. We multiply the divisor by this first term of the quotient, and then subtract the product from the dividend to find the remainder. Step 4. We divide the first term of this remainder by the first term of the divisor to find the next term of the quotient. Step 5. We continue this process, multiplying the divisor by the new quotient term, subtracting from the remainder, and finding the next quotient term until the degree of the remainder is less than the degree of the divisor. Therefore, our final result shows that the quotient is 3x cubed minus 9x squared plus 31x minus 104. And the remainder is 370x minus 207. This confirms our original formula. Where the degree of the quotient is n minus m, which is 5 minus 2 equals 3, and the degree of the remainder is less than m, which is 1, less than the divisor's degree of 2. To summarize the relationship between the degrees of polynomials in division, if f of x is a polynomial of degree n, and g of x is a polynomial of degree m, then 1. The quotient q of x will have a degree of n minus m. 2. The remainder r of x will have a degree less than m. This relationship is captured by our formula. F sub n of x equals g sub m of x times q sub n minus m of x plus r sub m minus 1 of x. Let's solve the example. Negative 2x squared plus 4x plus 7 divided by x minus 2. Before we start dividing, let's first set up our problem in the standard long division format. We'll place the divisor, x minus 2, outside the division bracket, and the dividend, negative 2x squared plus 4x plus 7, inside the bracket. Now, let's begin the polynomial long division process. First, we divide the leading term of the dividend, negative 2x squared, by the leading term of the divisor, x. This gives us negative 2x as the first term of our quotient. Next, we multiply the divisor, x minus 2 by negative 2x, which gives us negative 2x squared plus 4x. Now, we subtract this result from our dividend. Negative 2x squared plus 4x plus 7 minus the quantity negative 2x squared plus 4x equals 7. Since 7 is of lower degree than our divisor, x minus 2, we've completed the division. The quotient is negative 2x, and the remainder is 7. Therefore, we can express our answer as negative 2x plus 7 over x minus 2. Let's verify our answer by multiplying the quotient by the divisor and adding the remainder. We have negative 2x times x minus 2, which equals negative 2x squared plus 4x. When we add the remainder 7, we get negative 2x squared plus 4x plus 7, which matches our original dividend. This confirms our answer is correct. In summary, when dividing polynomials, we follow these key steps. First, arrange both polynomials in descending order of degree. Second, divide the leading term of the dividend by the leading term of the divisor. Third, multiply the divisor by this quotient term and subtract from the dividend. Fourth, repeat the process with the remainder until its degree is less than the divisor's degree. Finally, express the answer as quotient plus remainder over divisor. Let's begin by writing out our polynomials in standard form. Step 1. Let's verify that both polynomials are in standard form with terms arranged in descending powers. The dividend is x cubed minus 2x squared plus x, and the divisor is x squared minus x. Let's check the degrees of both polynomials. The dividend has degree 3, and the divisor has degree 2. Since the degree of the dividend is greater than or equal to the degree of the divisor, we can perform the division. Now, let's set up the long division process. We'll use a format similar to regular long division, where we put the divisor on the left and the dividend under the division bracket. In polynomial long division, we divide the leading term of the dividend by the leading term of the divisor to get the first term of our quotient. Let's perform the first step of our division. The first term of our quotient is x, which we get by dividing x cubed by x squared. Now we multiply the entire divisor, x squared minus x, by this quotient term x. This gives us x cubed minus x squared. We then subtract this result from our dividend. Let's bring down the next term, which is x. Now we continue the division process with our new dividend, negative x squared plus x. We divide the leading term of this new polynomial, negative x squared, by the leading term of our divisor, x squared. This gives us negative 1 as the next term of our quotient. We multiply the entire divisor by negative 1, which gives us negative x squared plus x. When we subtract this from our current dividend, we get 0. Since there's nothing left to divide, we have no remainder. Let's summarize our results. We found that when we divide x cubed minus 2x squared plus x by x squared minus x, the quotient is x minus 1 with no remainder. Since the remainder is 0, we can say that x squared minus x is an exact factor of x cubed minus 2x squared plus x. Let's verify our answer by multiplying the quotient by the divisor, which should give us the original dividend. Perfect! Our verification confirms that the quotient x minus 1 is correct. We've successfully divided the polynomial x cubed minus 2x squared plus x by x squared minus x using polynomial long division. Today, we're going to solve the problem 5x plus 9x cubed minus 4 divided by 3x plus 2. We'll work through this step by step using the polynomial long division method, which is similar to the long division you learned for numbers, but applied to polynomials. Step 1. Before we begin division, we need to rewrite both polynomials in standard form, ordering terms by descending powers of x. The dividend becomes 9x cubed plus 5x minus 4, and the divisor remains 3x plus 2. Note that we have a missing x squared term in the dividend, which will represent as 0x squared to keep track of our alignment during the division process. Step 2. Let's identify the degrees of our polynomials. The degree of the dividend is 3, and the degree of the divisor is 1. Since the degree of the dividend is greater than the degree of the divisor, we can proceed with the division. Step 3. Now we're ready to set up our polynomial long division. I'll format this similar to the long division you're familiar with. The divisor goes outside, and the dividend goes under the division symbol. Step 4. Let's start the division process. First, we divide the leading term of the dividend by the leading term of the divisor. 9x cubed divided by 3x equals 3x squared. This becomes the first term of our quotient. Next, we multiply the entire divisor by this term. 3x squared times 3x plus 2 gives us 9x cubed plus 6x squared. We then subtract this from our current dividend. 9x cubed plus 0x squared plus 5x minus 4 minus 9x cubed plus 6x squared equals negative 6x squared plus 5x minus 4. This becomes our new dividend for the next step. Step 5. We continue the process with our new dividend. We divide the leading term negative 6x squared by the leading term of the divisor 3x to get negative 2x. This is our second quotient term. Next, we multiply the divisor by negative 2x. Negative 2x times 3x plus 2 equals negative 6x squared minus 4x. Subtracting this from our current dividend, negative 6x squared plus 5x minus 4 minus negative 6x squared minus 4x equals 9x minus 4. This becomes our new dividend for the next step. Step 6. Let's continue with the final division step. We divide the leading term 9x by the leading term of the divisor 3x to get 3. This is our third and final quotient term. Next, we multiply the divisor by 3. 3 times 3x plus 2 equals 9x plus 6. Subtracting this from our current dividend, 9x minus 4 minus 9x plus 6 equals negative 10. Since the degree of negative 10 is 0, which is less than the degree of our divisor, which is 1, we've completed the division process. The remainder is negative 10. Step 7. Let's summarize our final result. When dividing 5x plus 9x cubed minus 4 by 3x plus 2, we get a quotient of 3x squared minus 2x plus 3, with a remainder of negative 10. We can express this in the form dividend equals divisor times quotient plus remainder. That is, 9x cubed plus 5x minus 4 equals 3x plus 2 times 3x squared minus 2x plus 3 plus negative 10. Let's verify our answer by multiplying the divisor and quotient, and then adding the remainder. First, we'll expand 3x plus 2 times 3x squared minus 2x plus 3. 3x times 3x squared equals 9x cubed. 3x times negative 2x equals negative 6x squared. 3x times 3 equals 9x. 2 times 3x squared equals 6x squared. 2 times negative 2x equals negative 4x. 2 times 3 equals 6. Combining like terms, 9x cubed plus negative 6x squared plus 6x squared equals 9x cubed plus 0x squared. 9x plus negative 4x equals 5x. And 6 plus negative 10 equals negative 4. So we get 9x cubed plus 0x squared plus 5x minus 4, which matches our original dividend. This confirms our answer is correct. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.